Hello, everyone, and welcome to another exciting episode of Backer Breaks It Down. Today, we're going to look at vertical and horizontal shifts. So, earlier, you investigated these shifts, also known as translations. Okay. And so I had you look at these diagrams, and in this diagram on the left, this is showing us a quadratic function that has been moved up 3 units. Okay, notice that the formula is y equals x squared plus 3. Okay, so that means this k value is positive 3. Now, what happened to the coordinates here? So I've highlighted 2, 4 on the parent function and 2, 7 on the transformed function. So the x coordinates didn't change. They stayed exactly the same, 2 and 2. So I'm going to write a little coordinate rule that simply says x stayed the same, okay, comma. What the y coordinates? The y coordinate went from 4 to 7. So that y coordinate increased by 3. 3 is the value of k, okay? So I'm going to write y plus k. So this is like our coordinate rule anytime we're moving or translating a figure up. Okay, notice that something similar is happening when we translate a figure down. So here, our quadratic function has been translated down 4 units, so the formula is x squared minus 4. And as far as our coordinates go, once again, the x coordinates stayed the same. This time, like the y coordinates went from 4 to 0. So they decreased by 4. So when we move a figure down, we're going to decrease our y coordinate by that however many number of units. When it comes to horizontal translations, we're talking right and left shifts. So for our function here on the left, notice the blue graph has the equation y equals the quantity of x minus 2 squared. Okay, and that our quadratic function has been moved to the right 2 units. So what happened to our coordinates? If you look, 0 became 2, right? And the y coordinates stayed the same. So when we moved our figure to the right, the x coordinate actually increased by whatever that shift was h, and the y coordinate did not change. When we shift a figure left, something similar happens, right? So here it's showing that the x coordinate went from 0 to -4, and the y coordinate did not change. Okay, so the x coordinate actually decreased by h, and then the y coordinate did not change. So as always, you need to be careful whenever your x's are involved in life and in math, okay? Because what we're seeing here is that the function says x minus h, and that means it's been moved to the right, yet the coordinate rule says x plus h. They don't quite match up. Likewise, x plus h indicates a shift to the left, yet the coordinate rule says x minus h. So just be careful whenever x is involved. This table in your notes summarizes all of our findings. It also mentions like, well, what would change? Would the domain of the function change? Would the range of the function change? Now, of course, we're talking domain and range when like neither is all real numbers. And so if you're simply moving a function right or left, that domain's going to change up or down. You're going to see a change in the range, right? So let's take a look at some examples involving translations. We are working with the figure on the right, and we want to basically write a new equation for each of these graphs. So I think that the easiest way to do this is to identify a key point and see what happens to it, right? So I am thinking this point right here looks like a good point to identify and track. And so that point there has the coordinates 0, 2. So let's locate that point on each of our graphs over here, okay? So in graph A, that point has been relocated, and that point has the coordinate of 0, 0. So it went from 0, 2 to 0, 0. How could that happen? Yes, this could happen if we move our figure down 2 units. Okay, and so we know that when we move a figure down, that our function should look something like this. Y equals f of x minus k. So we're going to write y equals f of x minus 2. So let's take a look at graph B. So once again, let's locate that key point that we're keeping track of. Oops, sorry about that. This time, it's located right here. That point is now at 0, 5. So what happened? Because it was at 0, 2. That's right. It went up 3 units. And so I can write a function equation like so. Y equals f of x plus k. So I'm going to write y equals f of x. And since it went up 3, I'm going to have plus 3. So that brings us to graph C. We'll locate our key point. Here it is. And it has the coordinates of 3, 2. So it was originally at 0, 2. Now it's at 3, 2. So what happened? You're correct. Our original graph was shifted to the right 3 units. So I can write an equation that shows that using this notation here. Y equals f, and then the quantity x minus h. So I'm going to have y equals f, parentheses, x minus, this went right 3, so minus 3. And then lastly, graph D, let's locate our point that we're tracking right here. It has an x-coordinate of -2 and a y-coordinate -1. Now remember our original point was at 0, 2, so I'll just like plot it right here so we have a nice visual. So what happened? You are correct. We had to shift the graph to the left 2 units and then down 5 units. So if I use my function table over here, I need to show left and I need to show down. So I'm going to write y equals f and then in parentheses x plus, for left, 2. And then outside of those parentheses, I'll show that it went down by going minus 5. So let's take a look at some problems where we don't have a visual. So in problem 2, it says the graph of g of x contains the point -3, 0. Write a formula for a translation of g that has a graph containing the point 5, 9. So what happened here? Okay, so we originally had an x-coordinate of -3 and a y-coordinate of 0. It was translated, and the new x-coordinate is 5, new y-coordinate is 9. So what caused this to happen? What would cause -3 to become 5? Okay. Now keeping in mind this is x and this is y, our x movement is either going to be right or left. Yeah, I agree. It definitely went right. And how many units did it go right? 8. Yes. And I can check that by simply going -3 plus 8, and that is 5. Wonderful. So what happened with our y-coordinate? You are correct. It increased. So what could have caused that? Correct. Once again, yes, we went up 9. So if I put these two descriptions together, and I refer to my little function notation table here, I have right and I have up. Okay, So I'm going to have, and this time it's g of x. I'm going to have g of, and then in parentheses, I'm going to have x minus, or right, so x minus 8. And then on the outside of those parentheses, since I'm going up, I'm going to have plus 9. And that would be my equation that represents this. Okay, so similarly, like number 3 is very similar, except it's only asking us about the x-intercepts. So remember, like the x-intercepts are where the graph crosses the x-axis. So like -5 and 3 are x values if they're x-intercepts. So what would be the x-intercepts of the graph of y equals f of x plus 2? So what happened? So the function notation is indicating this, y equals f of x plus h, which means it went left h units, okay? And that our coordinate rule tells us the x values would decrease by h. So x plus 2 tells us our function went left 2. The coordinate rule tells us our x values have decreased by 2. So if I apply that here to -5 and +3, so -5 decreased by 2, which means the new x-intercept is -7, and then 3 also decreased by 2, which would put me at 1. So -7 and 1 would be my new x-intercepts. 4 is similar to number 3. It says that a function is increasing on the interval from -1 to 5. Well, remember, whenever we describe intervals, we are using, once again, x values. Okay, so we're saying this increasing interval starts at x equals -1 and ends at 5. Okay, so what about the transform function y equals f of x minus 2? So the x minus 2 indicates that our graph has been shifted to the right 2 units, which means if you look at our coordinate rule, that means that all the x values increased by h, or in this case, by 2. So that's what I want to do to my 2 interval values. I want to increase each of my interval values by 2. So my new interval would be 1 to 7. So on problems 3 and 4, we are solely focusing on x values. Now let's talk about domain and range. Remember, domain is x and range is y. So in problem 5, it says the domain of a function is x is less than or equal to 12. I'm sorry, 0 is less than or equal to x is less than or equal to 12. That's our domain. And then the range is -4 is less than or equal to h of x is less than or equal to 2. We are working with the transformed function h of x plus 5 minus 12. So what does that tell us? Well, the x plus 5 tells us that our graph has shifted to the left h units. So in this case, it has gone left 5. And the -12, right, tells us that our graph has shifted down 12 units. So let me give you a very basic visual here. This is our function. Notice that it has a domain that goes from 0 to 12, and it has a range that goes from -4 to 2. And so we just said that our transformed function is moved to the left 5 and down 12, okay? So let's do that. So let's move it to the left 5. So 1, 2, 3, 4, 5. And then let's move it down 12. So right now it's at -4, that end point on the left is. So if I go down 12, Okay, that would put me right here. So graphically, I can see what my new domain and my new range is. My new domain goes from, here being -5. So -5 is less than or equal to x is less than or equal to, and then it ends here at 7. And my range, like I can see it, my range are my y values, and this y value goes as low as 16, well, -16, and then as high as -10. So I'm going to use the same notation we're using in this problem. So visually, we can see exactly what's happening here. So let's apply our rules and see if we can figure the same thing out without graphing it, okay? So I know it went left 5, and so I know that when you move something to the left, the x values decrease by that amount. So what that means here, that my x values are going to decrease by 5. Well, my x values are represented by the domain. So I need to decrease both of those values by 5. So I need to decrease 0 by 5. I need to decrease 12 by 5. Okay. And so when I do that, 0 minus 5 is -5. This is really messy, I apologize. 12 minus 5 is 7. So my domain is -5 to 7, and that's what we saw here. My range, all right, so this graph was shifted down 12. And so like I know that when you shift a graph down, the y coordinates are going to decrease by that amount. The range is representing my y values. So I need to decrease each of my range values by 12, okay? And so when I do that, I end up with -4 minus 12, right it below here, is -16. And then 2 minus 12 is -10. So my range goes as low as -16 and as high as 10. And that's exactly, or as high as -10, and that's what we got. Okay. And so those are horizontal and vertical shifts. So once again, always pay attention whenever your x values are involved. Notice that the function notation and the coordinate rules are not at all the same. Okay. All right. So when we see the quantity x minus h in our function, that means right. But what's happening are all those x values are increasing by h. So just be careful there. Anytime you have your function plus or minus a number, that's a vertical shift, and the coordinates follow the same rule. And that's how Becker breaks it down.